This episode is about categorical data. The key thing here is that it's nominal and ordinal. It's not numerical. We'll discuss the differences between these next. So nominal data is categorical data which can only take on, like all categorical data, a number of possible categories or values. These are often called levels in statistics if you're a statistician. Nominal data is categorical data where there's no intrinsic order in the values. So you might list the values in any order and they're still meaningful. And you can't count them from lowest to highest. They're often used for labels, or you can count within categories how many of a thing you've got. So you might have 10 cats and 2 dogs. In pandas, you can represent categorical type variables, and they can be unordered if you set the ordered option to false. I'll just show you what that means. First off, here we're going to import pandas. Then we're going to create a category. So C is going to be a type of categorical variable, and it's going to be able to take the labels cat, dog, or hamster. And if we print what this is, you'll see that it's 3 categories: dog, cat, or hamster. So the second type of categorical variable we'll be concerned with is ordinal data. It's almost identical to nominal categorical data, except that this does have a defined order in the data, and it might be alphabetical, it might be semantic. It's not normally numerical, but it can be, and product codes can be ordinal categorical data that isn't arithmetically meaningful, but is meaningful in a list in an order of products. So here's some examples here. The NATO phonetic alphabet, alpha, beta, Charlie, Delta, Echo, etc. A-level grades, while these do represent numbers, some mark levels, they're not in themselves numbers, and you can't do arithmetic on them, so they are categorical ordered ordinal data. The third example here is one that comes from the CIA in the report they wrote in the 1960s on uncertainty, and they're interested in how to describe probability to non-mathematicians, to non-expert decision makers. They compared, in fact, numbers and names, text names for probability, and concluded that it was easier for people to understand the naming system than it was the numerical system. So here's a set of labels that have a semantic meaning, and they're not in an alphabetical order, but a semantic meaning that they think people will naturally order these different levels in. And that goes from when you're very certain about something, you're probably certain that something's going to happen, probably not, right down to completely impossible. So I'll just show you one last thing here, which is comparing categorical variables. And here we've got C1, which is dog, and C0, which is cat. Is dog less than cat? Well, clearly in this case the answer is false, no. That's the end for now on categorical data. There are 2 types we've been worrying about. One is nominal and one is ordinal. So you can remember that nominal is about named items, but they don't have any order, and ordinal is about named items that have order. And very often that we're using these names as labels, whether they're labels for tree types or A-level grades, perhaps some kind of estimated probability system. Okay, thanks for now. Be back soon.